And next week we will do the discussion on regression, okay, linear regression, and then 2 weeks from now we will do the second exam, okay. So this is an overview. This is a repeat or recap of what we have learned within the past 2 weeks, okay. And in EduNext, you will also find links to video tutorials of on how to do these tests either manually and you also using Excel. Okay, so today is an overview, and I will review these problem examples that we have in the PowerPoint, and then I will give you some exercise problems that you will do in this class. Okay. Now, before I start, I need to emphasize the importance of having a proper experience with problem exercises, because the way that we teach this statistics class is we try to avoid too much discussion on the philosophical stuff, and we try to put more emphasis on the practical descriptions or practical discussions on the course materials, which means that you guys really need to do a lot of practice. Okay, you need to practice on your own. Certainly, just having signing your attendance and then logging into Microsoft Teams and then leaving your laptop away is not going to work. Okay, so because really, one of the most important thing in the statistics class is to have a good amount of exercise. Okay, so what I'm gonna do now is to show you again how to perform this hypothesis test before I let you do some exercise. And really, when we give you time to do the exercise, please do that. Okay, and we will check if you are doing that exercise later on. Okay,
Yeah.
without having us.
Hello, hello.
Yeah.
Yeah, I have uploaded the PPT in English. Yeah, the
Yep.
PDF in English. Should I also upload the exercise or later on?
Yeah, that's fine. You can upload it.
Okay, right.
So, where's the English version? Is it the in EduNext?
Do next week 8 module module.
8. Hang on a second. Let me. Yes, module 8.
Yeah,
Yep.
both in PDF.
Mm-hmm. Okay. Oh, okay. So this is in PDF format. Okay. So yeah.
I'll send you the PPT then to WhatsApp.
That's all right. We can just use the Indonesian version for the PPT. That's okay. So you guys can can download and read the materials, which is already uploaded and into next. That is in PDF format. However, I am still going to use the Indonesian version, which is in PowerPoint, because I need to draw some doodles on it. Okay. I'm sure that's not going to be a problem for you guys. Okay, so this is the first case that we'll discuss today, which is this is a one sample hypothesis test case in which we know the value of sigma. Now remember, sigma is different from S. Okay, so anything that is written in Greek letters usually refers to population parameter. So for example, population standard deviation is written as or symbolized as sigma, whereas sample standard deviation is denoted as S, the Latin letter S. Another example is population average versus sample average. So population average is symbolized by the Greek letter mu, and the sample average is usually denoted as x bar. Okay. So here the case is hypothesis test of population mean. Okay, now remember, we always test population parameter. We never test sample statistics because we already know the exact value of sample statistics. Okay, so we test for population average, in which sigma is assumed to be known or the sample is large. Okay, so if the size of the sample is large, then you can validly you can assume that S to represent sigma. Okay. Now let me repeat this in Indonesian for those of you who are having difficulty following me. Jadi kasus yang pertama ini adalah uji hipotesis rata-rata populasi di mana sigmanya diketahui, ya sigma adalah rata-rata simpangan baku populasi dan atau cuplikannya besar, ya. Cuplikan besar artinya ukuran cuplikannya lebih besar dari 30. Nah, kalau cuplikannya besar artinya kalau toh sigma tidak dianggap diketahui, kita boleh mengasumsikan bahwa S itu bisa menggantikan sigma. Oke. Okay, so let's start. So just to give you a little bit of a background to make the story more lively. So according to SNI is Standard National Indonesia. Okay, so this is an industrial standard that governs various types of industrial products. For example, in our case here, this SNI 157064 2004. This governs the quality standards for Portland Composite Cement, okay, so, or PCC. So PCC is one type of Portland cement that is widely used for various civil constructions, okay, for your homes, for roads, bridges, and so on. Okay. So according to this SNI, the weight of PCC product in each sack, okay, in Indonesian term we call it sack. Okay, sack is one cement bag, okay, satu kantong semen. So one sack of cement must contain either 20 or 40 or 50 kilogram of cement product in order to comply with the industrial standard. And with the weight deficiency that must not exceed 2% from the stated weight. So, for example, if the sack supposed to contain 20 kilogram per 30 kilogram of cement, then at a minimum it has to be 98% of that. So if it is below 98% times 20 kilogram, then it means it is a rejected product. Okay, so a cement factory wants to ensure that the average output of their cement bagging plant for the 40 kilo size is less than 39.2 kilogram. Okay, not less than 39.2 kilogram. And this is to comply with the SNI standard. Ya, okay. So jadi suatu pabrik semen ini ingin memastikan bahwa rata-rata output pabrik pengantongan mereka untuk produk 40 kiloan, ya, kemasan 40 kiloan, itu nggak kurang dari 39,2. Jadi kalau kalian lihat, 39,2 ini adalah 98% kali 40 kilo. Ya, jadi mereka ingin memastikan, intinya mereka ingin memastikan bahwa pabrik ini mematuhi SNI. Ya. So for that purpose, we take one sample of the product, which consists of 20 sacks. Ya. Jadi satu cuplikan ini isinya 20. Jadi N sama dengan 20 atau ukuran sampelnya adalah 20. And then we remove the content and we weigh the content. Okay. And it turns out that the sample average of that 20 sacks of cement is 38.9 kilogram per bag. Okay, per sack. Yeah. Now, based on historical record of the plant, the population standard deviation, the sigma, is assumed to be or is known to be 0.85 kilogram. Now, of course, going back to our discussion, in most cases we cannot perform census for a very, very large population. Okay, which practically this one is. So you can imagine that one cement plant will produce hundreds, if not even thousands of cement bags per day. So it's not possible. It's actually impractical to perform census. So there's no way that we can measure each and every bag. Okay, how much cement is contained inside it. It will be too expensive. Okay, so we have to rely on sampling. However, because the sample size is so large and the data has been accumulated for a long time, then the plant the company assumes that they know sigma. Okay, they know sigma to be 0.85 kilogram, okay, based on the historical data. Yeah. Okay, so at a significance level of 0.05, remember, significance level is different from confidence level, and the relationship is significance level is 100% minus confidence level. Okay, and the one that is denoted by the symbol alpha is tingkat keberhasilan or significance level. Okay, and you should remember from our past discussion that the 5% in alpha denotes the risk of making a type 1 error. Okay, now go back to your notes and refresh your memories. What is the definition of type 1 and type 2 error? Okay, so again, alpha refers to the risk of making a type 1 error. Now, please underline the word risk. It doesn't mean that your whole procedure will be wrong. It's just that everything contains uncertainty, including our hypothesis test. So when we perform hypothesis test, remember that we do this based on sample. Now, there will always be variation from sample to sample. When we take 20 sacks of cement today and compare that to the data that we sampled yesterday or 2 days ago, or the sample that we will take tomorrow, then there's always a chance that we will get a different number each time, right? So this time we get an average sample mean of 38.9 kilogram per sack. Who's gonna say that we will get the same number tomorrow, right? Maybe when we do perform the same sampling tomorrow, we will get, let's say, maybe 39.1 or maybe 39.5, whatever. Okay, so there's always variation in measurement results. Okay, and so the consequence of that is that the conclusion that we draw from any hypothesis test always contains some probability of error, risk of error, meaning the conclusion that we draw might be wrong. Okay, because this is based on data that contains uncertainty. Okay, ya, jadi filosofinya apa sih sebetulnya tingkat keberhasilan ini ya? Ingat, tingkat keberhasilan simbolnya adalah alfa. Alfa adalah risiko. Ya, risiko itu artinya peluang untuk sesuatu yang belum kejadian. Ya, jadi 5% itu maksudnya adalah risiko kita melakukan kesalahan tipe 1. Nah, kalian nanti kembali periksa lagi catatan kalian ya. Apa itu pengertian kesalahan tipe 1 dan kesalahan tipe 2? Itu penting banget. Oke. Nah, bukan berarti kemudian kalian melakukan kesalahan dalam uji hipotesisnya, enggak ya. Tetapi bahwa kita berurusan dengan sesuatu yang ada ketidakpastian ya. Contoh yang kita lihat sekarang, oke, kita ambil 20 sak semen, kita ukur berat semen netonya ya per kantong dan didapat 38,9 kilo per sak. Itu sekarang. Kalau besok kita sampling lagi, bisa jadi angkanya lain. 38,9 ini kalau kita bandingkan dengan data minggu lalu mungkin lain angkanya ya. Nah, itu artinya ada ketidakpastian. Kita berurusan dengan random variables. Oke. Nah, data awalnya saja, data dasarnya saja sudah mengandung ketidakpastian, maka kesimpulan akhirnya pun juga mengandung ketidakpastian. Dengan kata lain, kesimpulan akhir dari uji hipotesis itu tidak boleh dianggap sebagai kebenaran yang mutlak. Ya. Di sana ada ketidakpastian. Jadi selalu ada risiko kita melakukan kesalahan. Apakah kita melakukan kesalahan atau enggak? Ya nggak tahu. Yang penting kita bekerja dengan suatu tingkat risiko tertentu. Dan kita tetap menjaga mindset bahwa this all contains uncertainty. So whatever result that I'm reporting, there's a chance that it might be wrong. Whether it's wrong or not, I don't know. That's the limit of my knowledge. Okay. All right. So again, at a significance level of 5% or equivalent to confidence level of 95%, prove that the company did not violate this SNI standard for 40 kilogram PCC product. Okay. Now, again, underline the words in blue there that the factory wants to prove that they did not evaluate, they did not violate SNI standard. Ya, jadi pabrik ini ingin mengklaim bahwa mereka tidak melanggar SNI. Okay, pada tingkat keberhasilan 5%. All right, so how are we going to do this problem? Okay. Now go back to the original claim. What is the original claim that we want to prove, or they want to prove? Okay, so they want to prove, okay, they want to prove that the average filling weight of the PCC is not less than, okay, not less than 39.2. Yeah. So if you put this in mathematical form, then we obtain this one here. Okay, let me move to presentation mode so I can draw some doodles. Yeah, okay, there we go. So this is the initial claim that we want to prove, okay? This is in mathematical form. So again, the initial claim is that the average filling weight of the PCC is not less than 39.2. Okay? Not less than means larger than or equal to 39, right? Claim number two. So if the claim is wrong, if the claim turns out to be wrong, then the statement or the condition that would become true is the complementary statement, which is this one here. Okay, so if you remember our what do you call it? Boolean algebra, algebra Boolean, I think. Yeah. So this one, this is pernyataan komplementer, ya. Is complement of, right? So if this one is not true, then the one that becomes true is this one, of course. Okay. All right, so between those two statements, the original claim and the statement that would become true if the claim is wrong, then we select the one with the that contains equality as the null hypothesis, and the one that contains inequality to be the alternative hypothesis. So for this problem, right, the one that contains equality is, of course, the original claim. Okay, so this one contains equality. How do we know that it contains equality? Because it has this sign here, larger than or equal to. So this one contains equality, whereas this one, this is an inequality statement. Right? Oops. Okay. So therefore, the first statement or the original claim will become the null hypothesis, and the second statement will become the alternative hypothesis, like that. Okay, this one here. Now the next step is to calculate our test statistic. Yeah, statistic uji. Okay, so the first one, again, first step is construct. This is the simplified version of hypothesis test steps. So the first one is construct the hypothesis statement, H0 and H1, right? And the second step is calculate test statistic. Okay, which in this case, because the sample size is small, but sigma is assumed to be known, then for this case, the test statistic is Z0, Z0, ya. Jadi dalam kasus ini karena meskipun ukuran sampelnya kecil, tetapi sigmanya dianggap diketahui, dan yang kita uji adalah rata-rata. Maka statistik uji yang cocok adalah dalam kasus ini adalah Z0. Okay, and you can see that from the problem we have all of these data available. Okay, so we have the sample mean, right? We have the assumed population standard deviation, and we have the sample size. So all we have to do is just to plug in those numbers to this formula for Z0. Okay, which gives us this number here, minus 1.578. Okay, So step number 3 is we look up critical values. Now remember, guys, critical values are those that define the limit of the or the boundaries of the rejection region. Okay, the H0 rejection region. And for the variable z, okay, for variable z, for alpha 0.05, and this is, by the way, a one-sided test, right? Okay, so this tells us that this is a one-sided or one-tailed test. Okay, so this is a one-tailed left-hand side test. So we obtain the z, the critical z, to be minus 1.645. So if I were to draw this, so this is a z distribution, right? Sorry about the messy graph. So this is the z distribution, right? The center line is, of course, z equals 0, and then it extends to z plus infinity to z minus infinity. Okay, and we are looking for the value of z. This is the critical z, right? Z for which the alpha is 0.05. So in other words, the area under the curve, which is bounded by this z value, okay, so this area is, of course, equal to alpha. And this area is 5%. So the value of z that corresponds to such situation is, and by the way, this is on the left-hand side, so the value of z is minus 1.645. Again, go back to your notes and look at the empirical properties of z distribution. Okay. Now, as I remember, I think I have told you guys, okay, that being engineers, of course, we're not teaching you to memorize stuff, to memorize formulae or memorize numbers. But that being said, there are several numbers that will make your job easier if you memorize those. And one of those numbers are z, okay, the value of critical z at 5% of alpha and 2.5% of alpha. Okay, so one is 1.645 and the other one is 1.96. Okay. All right. Okay. And as you can see on the figure that just popped up there. Okay. Oh, sorry about that. There we go. So the alpha is, so the area under the curve is 5%. Okay. And the z value, the critical z value for that corresponds to that area is minus 1.645. Okay. And our test statistics is minus 1.578. Okay, so it is located just on the right-hand side of the critical z. So that means that the test statistics is located in the non-rejection region. Okay, so in other words, we can conclude that there is not enough evidence. Okay, there is not enough evidence to refute the statement that the average filling weight of this PCC product is less than 39.2 kg per bag. Oke. Ya, jadi saya ulang dalam bahasa Indonesia ya. Jadi setelah kita cari nilai Z kritiknya adalah minus 1,645, itu yang terkait dengan alfa 5% di sebelah kiri ya. Kalau alfa 5% di sebelah kanan, maka Z-nya menjadi plus 1,645 ya. Kemudian Z0-nya sendiri statistik ujinya adalah minus 1,578. Jadi posisinya itu tepat di sebelah kanannya, sedikit di sebelah kanan dari nilai Z kritik. Dan ini adalah daerah non penolakan H0 ya. Nah, untuk masalah menentukan mana daerah penolakan dan mana daerah penerimaan, saya tidak suka menggunakan istilah kiri dan kanan karena itu bisa membingungkan, tergantung dari ujinya, sisi ujinya, nilai kritiknya dan sebagainya. Kalau saya lebih suka menggunakan istilah sebelah luar, ya. Jadi daerah penolakan H0 selalu letaknya di sebelah luar. Luar itu bisa di kiri, bisa di kanan, bisa dua-duanya. Oke. Nah, yang saya maksud tadi dengan daerah sebelah luar tadi ya. Oke. Right. Again, because the Z naught is located in the non-rejection region of H null, then we conclude that H0 is not rejected. Okay. In other words, there is not enough evidence to reject H naught. Okay. To reject the statement that the average filling weight is not less than 39.2. Okay. All right. So in other words, going back to our original claim, the claim from the cement factory is supported. Ya, jadi tidak ada bukti yang menolak klaim awal dari perusahaan tadi. Ya. Alright, any questions here? No? Okay, if not, I'll move. Yeah, go ahead.
I still don't understand if the Z0 is inside the area, then we accept the argument, or no? Thank you.
Okay, let me repeat the conclusion. Okay, so going back to the graph here. Okay, so the rejection region for H naught is this one. Yeah. Okay. So rejection region is always located on the outside of the graph. Yeah, never on the inside, but always outside, sebelah luar. Okay. And the boundary for that rejection region is the critical z value, which is in this case is minus 1.645. Ya, jadi ini adalah nilai kritiknya. Okay, the critical value of z. Yeah. So and the critical value only depends on the alpha. It doesn't depend. It does not have anything to do with the sample data. Yeah. Okay, so this orange arrow is fixed. This one is fixed unless you change the alpha, okay, or unless you change the hypothesis, let's say from one-sided into two-sided, for example. So the orange arrow, again, this one is fixed. It does not have anything to do with your data. Now, the one that has a lot to do with your data is the black arrow, the Z naught, okay, the test statistic, because this one is calculated for your sample. Okay. Now, because it is located in the interior, okay, relative to the critical zone, okay, relative to the critical Z value, this one is located in the interior. Jadi Z0-nya terletaknya di sebelah dalam, ya. Saya lebih suka menggunakan dalam dan luar ketimbang kanan kiri, karena kanan kiri yang membingungkan, ya. Jadi Z0 ini letaknya di sebelah dalam. It is located in the inside. To the inside with respect to the critical value. So, in other words, Z naught is located in the non-rejection region. Okay. Yeah. Well, you can say acceptance region, but actually statistically, non-rejection and acceptance region is have different meaning. But anyway, so because the Z naught is located here, we do not reject H0. Okay, we do not reject the null hypothesis. Had it been located there, if the Z naught if is located there, seandainya diletaknya di sini, maka kita tolak H0. Okay. I hope that's clear enough. Okay, so let me repeat that again. The critical value is pretty much fixed. It only depends on your alpha. In other cases, for example, for t-test, okay, the critical value depends on two things, the alpha and the nu. Now remember, nu is degree of freedom. Yeah. it doesn't depend on your data, on your measurement data. The one that is dependent on your data is the black one, the test statistic. Yeah. So this one can move about based on your data. This one is fixed. Okay. It is fixed by the value of alpha again, and the way you set up the H1, whether it's one-sided or two-sided test. Okay. I hope that's clear enough. Is it clear enough? Yeah.
Yes, sir.
Okay. All right. Okay, the second one, this is the case where sigma is unknown and the sample is small. Okay, now I'm not going to go through all of the detail in this example here. You can read it yourself. Yeah. So the case here now is random sampling of 10 pieces of ingots, aluminum ingots. Ingots is yeah, they look like this. Okay, so ingots are solid units. They're based on standard weights, so and standard dimensions. So these would be solid pieces of metals with sufficient degree of purity so that they can be melted and formed into final product. So they don't need, generally speaking, they don't need further purification. Ya, jadi ingat itu adalah logam-logam batangan yang kemurniannya sudah cukup untuk dibentuk menjadi produk akhir. Ya, mau dicor, dipupuk dan sebagainya. Jadi secara umum ya biasanya kalau sudah bentuknya ingot ini tidak perlu dimurnikan lebih lanjut. Kecuali memang produknya menuntut kemurnian yang tinggi sekali. Oke. Okay? So we take 10 pieces of aluminum ingots and measure their weights and we obtain these numbers. Yeah. Okay. And we would like to prove that the average weight of ingot per piece, okay, exceeds 22.5. Okay. Yeah. So let us see how the claim is look like. So the initial claim that we want to prove is that the average weight per ingot exceeds 22.5. Okay. So in a mathematical form, we say it like this: mu larger than 22.5. Yeah. And if this initial claim is wrong, then the correct statement will be this one here: mu less than or equal to 22.5 kilogram. Now, can you answer me? Out of these two statements, which one will become the H null? Is it the first statement or the second one?
Second one.
Yep. Clearly the second one because it contains equality. Now, this example tells you that it doesn't always the case that the first statement or the original claim becomes the H naught or the H null. It depends on how you frame the statement, right? It depends on what you want to claim to begin with. So in this case, we want the company or whoever is doing the test wants to claim that the average weight of one ingot exceeds 22.5, right? So the original claim itself is already in inequality form. It's not equality form, but it's inequality form. Ya. Jadi karena klaim awalnya bentuknya adalah ketidaksamaan, maka klaim awal ini menjadi H1. Dan pernyataan keduanya menjadi H0. Okay. Yeah. And so the complete hypothesis statement for this case is like that. Okay. And from the sampling data, we calculate the sample mass. The average of the sample mean is 22.01, and the sample standard deviation is 0.92 kilogram. Now, because we don't know the value of sigma, then we have to use t-test. Okay, so let me correct that. We don't know the value of sigma, and the sample is small. It only contains 10 pieces of ingots, so we cannot perform z-test, but we have to perform t-test. Yeah, and that is the value of the test statistics. Okay, so all you have to do again is just to plug in the numbers. Yeah, the x bar is 22.01, mu sub 0 is, of course, this one here. This is the reference value, okay? And S is, we already have S, and N is the sample size, okay? So this would be square root of 10. And we calculate and we obtain minus 1.685, right? Okay. And then we find the critical t-value for alpha 0.05. Okay, now the situation is quite a bit interesting. Okay, now pay close attention to this one. Clearly from this statement, from the alternative hypothesis, that this is a one-tailed right-hand side test, right? Jadi jelas dari sini bahwa daerah penolakannya itu satu sisi sebelah kanan, karena ini adalah uji satu sisi sebelah kanan, ya. Okay. However, the value of the data is such that T0 is minus. Okay, and that's, that doesn't mean that your calculation is wrong. It's just the way it is. Okay, this is just the way the problem is formulated. Okay, and this happens because the sample mean is less than the reference value, yet the problem is a one-sided right-hand side hypothesis test. Okay, so then we find the critical value for alpha 5% for one-sided right-hand side test at a degree of freedom of 9, and we obtain the value to be 1.833. Okay, all right. So the critical t-value is 1.83. Sorry, this one is not very clear. Okay, so this is the critical t-value. This one here. Let me draw some doodle on it. Okay. So this one is critical t. So this is t at 0.05 and degree of freedom of 9. So this equals to plus 1.833. Okay. However, our test statistic, okay, our T0 is here. Clearly, it is located on the other side. So this is minus 1.685. Okay, and where's the rejection region? The rejection region is here, of course, because it is defined by this one and by this one. Okay, so this is this is a one-tailed right hand side test, meaning the rejection region is only one-sided and it is located on the right hand side, not on the left hand side. Okay, so for this case, the T0 is located far away inside the non-rejection region. Okay, right? This entire graph, so anything from this point to the left, okay, all the way to minus infinity, all of these constitutes the non-rejection region. Okay, and this is the reason why I don't like to work with left-hand side. Ini alasan kenapa saya nggak suka bekerja dengan pemikiran, oh kalau daerah penolakan itu adanya di sebelah kiri atau sebelah kanan. Don't use kiri kanan, but use inside outside. Pakailah pengertian daerah penolakan itu letaknya selalu di sebelah luar dari kurvanya. Ya, okay. Alright. So in conclusion, there is not enough evidence to reject H0. Yeah, the null hypothesis. All right. Any questions here? Now, think about this on your own. This one here. So what happened? Or let's do this as an exercise, okay? So what happens if we want to prove that the average is not more than 22.5? Okay. Now, do this on your own now. Okay. I need to take a break. I need to take a 5 minute break or 10 minutes break. So ini kerjakan ya, kalian kerjakan yang saya kotakin warna oranye ini. Okay. So this one here. Okay. Where is my pen? Okay, there you go. This one here. Okay. So what if what if the initial claim is changed? What if we want to prove that the sample, that the population mean does not exceed 22.5? So of course, the original claim will be changed, and also the statement that will be true if the original claim is changed is also changed. Ya, jadi H0 dan H1-nya pasti akan berubah. Oke, silakan dicoba. Ya, I'll be back in a few minutes. Okay, all right. So what happened if we change the initial claim to be that the mean of the ingot weight is not more than 22.5. So how does the H naught now look like? Is it changed? Anybody? What is the H naught? The H null?
It's the same, sir.
Yep. Stays the same like this. And then the alternative hypothesis. Oh, sorry about that. Sorry. Let me erase that. Okay, so what is the sign for the alternative hypothesis? So now this becomes what?
Is it lesser?
Yeah. Okay, so now this becomes the one-tailed left-hand side. Let me just abbreviate HS, left-hand side. Okay. And now, of course, if we draw the relative position of the T0 and the critical T, yeah. So now this is the T critical, right? This is the T 0.05 at 9 degree of freedom. So now the rejection region is on the left hand side. Okay, because this one here, right? And the T0, okay, the T0 doesn't change in this case because the data stays the same. So the sample mean is the same. The mu naught is the same, S is the same, and also N is the same. So thereby, the T0 is also stays at minus 1.685. Now, of course, because the T distribution is symmetrical, okay, then we can pretty much just mirror the value of the critical T value from the previous problem into this one here. Okay. Oh, sorry. This would be T tail is split into. Okay, so yeah, right. So this one is equal to minus 1.833. Okay. And this one, so now minus 8. This is the T0. Yeah, the T0 is, what am I doing here? Wait. Yep, the T0 is minus 1.685. Okay. So as you can clearly see, right, the rejection region is located to the outside of the T0. Yeah. So minus the boundary for the rejection region is minus 1.83, whereas the T0 is minus 1.68. So the T0, in other words, is located to the inside of the critical value. So it is located, again, it is located in the non-rejection region of H0. Okay, so the conclusion stays the same. We don't have enough evidence to reject H0. Okay, even though we changed the hypothesis or the initial claim. Okay, now this is not always the case, and it really depends on how close, essentially how close your your critical value and your test statistics are. Okay. Now, let me give you an example. Okay, this is just a hypothetical example. It doesn't relate to any. Okay, before we go here, let me give you an interesting situation. Okay. All right. So let's say that it doesn't matter. It could be Z distribution, it could be T, it could be F, doesn't matter. But let's say that this is, well, let's call it Z distribution, okay? So this is Z equals 0, right? Okay, and okay. Okay, so we have a two-sided hypothesis test like this. Right, so of course the area is, this one is alpha divided by 2. This is also 1/2 of alpha, usual. Okay, and let's say if alpha is, if the alpha is 5%, then so if alpha is 5%, then this is C equals to 1.96, right? This is if the alpha is 0.05 and two-sided. Okay, and this one is Z equals to minus 1.96, right? Okay, now let's say, suppose your Z naught is located here somewhere. Okay, so your Z naught, now this is the test statistic, so this is the one that you calculate from your data. Okay, let's say that your Z naught is 1.8. Okay, the Z naught is 1.8, right? So here in this situation, right, obviously the conclusion is we do not reject H0, right? Okay. Now, if for some reason then a valid argument can be made that, okay, what if we change the hypothesis? What if we change the alternative hypothesis into a one-sided test? Okay, let's say that there is no physical argument that prevents that. Okay, jadi misalnya gini, uji ini di-challenge, ditantang. Okay, gimana kalau kita ubah ujinya menjadi uji satu sisi sebelah kanan, dan katakanlah misalkan tidak ada batasan fisik yang melarang itu, ya. Okay, so now the situation will be, of course, would be quite a bit different, right? So now we have, okay, so now the alpha, the 0.05 alpha is all collected on the right hand side, right? So sorry about that, I need to write down this one here. Okay, so the H naught is still like this, but now it is argued that H1 can be converted into this one for some reason. Okay, and we can say that the reason is valid. Okay, so now everything, both on the, this alpha on the right hand side will have to be moved, sorry, on the left hand side will have to be moved on the right hand side, right? So now we only have, one rejection region only on the right hand side. And the Z now, if you remember, now changed into 1.645. Okay. The alpha now is, this is 0.05. Now remember here, this one is 0.05 divided by 2. So this is actually 0.025, right? Okay, so because we're collecting everything, we're collecting both rejection regions on one side, then of course the critical Z value will shift inwards, ya. Jadi karena sekarang ujinya kita ubah menjadi, katakanlah ada alasan yang valid untuk mengatakan, oke, kenapa nggak kita ubah, coba H1-nya menjadi mu lebih besar mu 0, ya. Nah, sekarang menjadi permasalahan uji satu sisi sebelah kanan. Jadi alfanya kita kumpulin ke sebelah kanan semua. Rejection region-nya menjadi hanya satu di sebelah kanan. Ya, karena itu nilai Z-nya bergeser ke sebelah dalam. Coba untuk kita tidak bicara kanan kiri, tapi sebelah dalam luar ya. Jadi Z-nya bergeser ke sebelah dalam untuk mengakomodir daerah di bawah kurva yang lebih luas sekarang. Tadinya hanya 0,025, sekarang bertambah menjadi 0,05. But in this case, because we don't change the data, then the Z0 is still sitting at 1.8. Right? So the Z0 is still, I'm just drawing a number here, guys. Okay, so just hear my story. Okay, so we assume that we don't change the experiment. All we change is the hypothesis, right? But now, lo and behold, okay, now the Z0 is located in the rejection region of H0. So now the conclusion is reject H0. Ya, simsalabim kesimpulannya berubah. Oke. Okay. Now, can anybody tell me why this oddity happened? Ada bisa jelasin nggak kenapa kok kejadian ini terjadi? Kita mengubah hipotesisnya, lah kesimpulannya berbalik. Kenapa? So this happens whenever your test statistics is what? Look at it here. Let me give you another example. What if, okay, what if the Z0 is, I don't know, let's say 1.5. Let's say what happened if the Z0 is maybe 1.5. Okay, so here the Z0 is 1.5. Now, it doesn't matter if we change H1, the conclusion stays the same. We do not reject H0, or conversely, let's say that if the Z0 is somewhere out here, okay, the Z0 is 5, okay, 5.0, right? And here the Z0 is also 5.0. So now in this case, in the second case, in the latest case here, it doesn't matter how we formulate H1, okay, we still reject H0 because the Z0 is so far away to the outside that it doesn't matter if we change the hypothesis. Okay, so the ambiguity of a hypothesis test occurs whenever your test statistics sits too closely to the critical value. Okay, so this is what happened in the original case here, this one, right? Z0 1.8, this is quite close to the critical Z of 1.69, sorry. So as you change the hypothesis into one-sided, what is previously concluded as we do not reject H0 now becomes we reject H0. it's not that you changed the experimental data. You did not change any data at all. All you did was change the H1. We changed the hypothesis. Okay. Jadi kita nggak ngubah data sama sekali nih ya tadi ya. Kita hanya mengubah hipotesisnya dari yang tadinya dua sisi menjadi satu sisi sebelah kanan kayak gini. Ya. Nah, kesimpulannya berubah. Kenapa? Karena nilai kritiknya, karena statistik uji kalian itu terlalu dekat dengan nilai kritik. Jadi mengubah hipotesis artinya mengubah nilai kritik. Okay? Changing your hypothesis means changing your critical value. Okay? So if your critical value sits too closely to the test statistics, then the ultimate conclusion might be reversed when you change the hypothesis. Okay? Of course, this all depends on whether there's a valid argument of being able to interchange this claim. Ya. Jadi ini memang tergantung dari apakah ada nggak dasar argumen untuk mengatakan oke, saya mengubah H1. Ya. Dalam sebagian kasus ada, dalam sebagian kasus lagi nggak ada. Oke. Tapi intinya yang ingin saya sampaikan adalah hati-hati dengan apa yang ingin kalian buktikan. Ya. Oke. Because you might get a different answer depending on what you want to prove. Yeah. All right. Okay, so the last example, this is a continuation of case number 1, the cement bagging weight. Yeah. So the cement factory suspects that there has been an increase in variance, ya. Jadi mereka curiga ada peningkatan variabilitas, peningkatan sebaran, ya, sebaran berat pengantongan semen, which exceeded the historical value for standard deviation, which is supposed to be 0.85 kilogram. Okay. So sigma is supposed to be 0.85. Now they suspect that now they encounter a wider variation of product. Okay, so they performed sampling. So they took 12 bags or 12 sacks from the baking plant, and they weighed the content of those 12 bags, and they obtained a sample mean of 39.4 kilogram per bag, with a standard deviation of 0.91 kilogram. Okay, so we want to confirm the suspicion at a confidence level of 95%. Yep. Okay, I think that's pretty clear. So the claim that we want to prove is, where is my pen? Oh, keep happening to me. Yeah. So the claim that we want to prove is that sigma, okay, is larger than 0.85. So again, the company suspects that their process standard deviation has increased beyond its historical value of 0.85. Okay, so they want to prove that the initial claim is that sigma is larger than 0.85. Okay, or if we put it in variance, the variance is larger than 0.722. So all you have to do is just to take the square of it. Okay, if that claim is wrong, then the statement that becomes true is, of course, the complement. So sigma is less than or equal to 0.85 kilogram. Okay, and right off the bat, you can see that the first statement contains equality, and the first statement contains inequality, and the second statement contains equality. Okay, so this one, the first statement becomes H1. And the second one becomes H0, becomes the null hypothesis, right? So we have the complete hypothesis statement to be like this. So H null, the variance is equal to the reference or historical variance, which is 0.722, and the alternative hypothesis is that the variance, the population variance, has exceeded 0.722. Okay. All right. And the sample data is like this. So the standard deviation is 0.91 and n or sample size is 12. And that's your test statistic. So this is a problem when we compare a variance with a reference value. So there's only one data set. So this translates into chi-square test. Okay, so that's the value of your chi-square. All you have to do is to find the critical value, and if we depict this graphically, then we will obtain that that graph on the right-hand side here. Okay, yeah, the probability is 0.05. Yeah, this is a one-sided test, and the critical value is 19.68. Okay, this is the critical value. So if you look at the test statistic, it is located here somewhere to the inside of the rejection region. There you go. So this means that we do not reject H0. We don't have enough evidence to reject H0. Okay. Next, all you have to do is to frame up the conclusion in verbal, okay, in words that reflects the correct mathematical statement. Oke. Jadi kesimpulan itu kita kembalikan lagi ke klaim awal yang ingin dibuktikan, ya. Klaim awal yang ingin dibuktikan adalah bahwa telah terjadi peningkatan varians melampaui nilai historisnya. Nah, kesimpulannya tidak terdapat cukup bukti untuk mendukung kecurigaan tersebut. Jadi pada saat kita mengambil kesimpulan, kita kembali lagi ke sini. Klaim pertama apa sih yang mau dibuktiin, gitu ya? Okay, so when we want to frame up our conclusion in words, so we need to go back to our original claim. Yeah. In this case, the original claim was that the process standard deviation has exceeded its historical value. Okay, and because we don't have enough evidence to reject H0, then we say that we don't have enough evidence to support that suspicion. Okay, so again, this sounds like quite a bit like a wordplay, but this is quite important. Okay, so whenever you draw your conclusions, go back to the original claim that you want to prove, bearing in mind that the original claim could be translated as H0 or as H1, depending on how you state your original claim. Okay, yeah. All right, if you if it's not obvious right now, that's okay. You can just keep on reading these videos, okay, viewing these videos and reading the handouts again to really. I realize that it may take some time to get this in our brains, okay, in our minds, all of these wordplay, okay, but the principle is that whenever we want to draw a conclusion, we have to go back to the original claim. Okay, whether the original claim was H0 or H1, it doesn't matter. What we want to prove is the original claim. Okay. All right. Gee, what time is it? Okay, it's 8:27, so I think we have time, a little bit of time to continue to the second part, which is, yeah, this one. All right, let's do a 2-minute break. I need to have to drink some water, and we'll we'll continue at 8:30. Okay, so in 2 minutes. Okay, just need 2 minutes. Oops, sorry. Okay, we have a little less than 15 minutes left in our class today. So let's just move on. Bu Winnie? She's away from keyboard. That's fine. That's all right. We have prepared a set of exercise problem for you guys. So that problem will be uploaded in EduNext, and well, I'll tell you what. Just for the sake of variation, okay. So you guys will do that as a homework. Okay, so we want to make sure that at least some of you will do that problem by yourself. Hopefully, all of you will do that. So that will be turned in next week as a homework. Okay, it's a set of 3 problems, and just so you know, that problem was given as an exam problem many years ago, almost 10 years ago. Okay, so you know, it gives you some idea of what the exam problem will look like. Okay, all right. Okay, so continuing on to our discussion. So we now in the 2-sample hypothesis test. The first one is the easier one. Okay, so in this case, the sigmas are assumed to be known. Now remember, now we're dealing with 2 sigmas because we're dealing with 2 samples. Okay, and it doesn't mean that the sigmas has to be equal, but they have to be known. Okay, now, okay, remember, this is sigma, not S. Okay, so the first one is this is the problem is, or the case is a cracker packing line, ya, mesin pengisian produk keripik gitu ya, and the net mass written on the label on the label on the packaging is 296 grams. So this is what is written or printed on the bags of the chips. Okay, so of course this filling machine has to aim for that targeted net mass. Okay, now the filling is being done using 2 machines. Okay, and we denote them as machine A and machine B, right? Okay. Machine A is quite a bit older compared to machine B, and it has been known that the standard deviation from machine A is 5 grams. Okay. Now, recently the plant installs machine B, and the machine B exhibits a standard deviation of the filling weight of 3 grams. Okay, so both are known. Okay, both are assumed to be sigmas. So these are not S, these are not sample standard deviation, but these are population standard deviation from machine A and machine B. Okay, now because we want to check the equality of the means, okay, the equality of the means of filling between these 2 machines, then we take some random samples from both machines. Okay, so from machine A, we take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we take 12 bags of chips and we measure the actual weight of chips inside those. Okay, so these are the data for machine A and this is the data for machine B. For machine B, we pick out 15 bags. So the sample size is different. Okay, so for the machine A, yeah, the sample size is 12, and here the sample size is 15. Again, from the problem, we also know sigma A, so the population standard deviation of machine A is assumed to be known at 5 gram, okay, and sigma B is 3 grams. Okay, now we are asked to perform a hypothesis test to check the equality of the means. Okay, so remember, we check the equality of the means. In this problem, it is not valid to check the equality of variance. Clearly, the variance are different, right? We assume to know the exact value of sigma. Sigma A is 5, sigma B is 3. So there's no point in asking if sigma A is equal to sigma B or not. Clearly, they are not equal. Yeah. What we want to test is the equality of means in this case. Ya, oke. Jadi jangan bingung ya. Dalam kasus yang kita lihat ini, kita menguji kesetaraan rata-rata pengisian, rata-rata berat pengisian per kantong keripik ya dari mesin A dan mesin B. Ya, di mana sigma A dan sigma B-nya dianggap diketahui secara eksak. Jadi tidak valid lagi kita menanyakan apakah ini variansinya sama nggak antara A dengan B. Udah jelas nggak sama. Ya. Varians simpangan baku A itu 5, simpangan baku B itu 3. Jadi itu tidak usah dipertanyakan lagi. Kita anggap diketahui secara eksak. Yang dites adalah kesetaraan rata-rata pengisian, bukan simpangan baku. Oke. Dan kita diminta untuk bekerja pada alfa 10%. Okay, so let's get to it. Okay, so as usual, we frame the initial claim. So the initial claim is that the average of net filling mass from both machines are equal. Yeah, so that's the initial claim. Again, let me repeat this. The initial claim is that both machine A and machine B produces the same average filling weight per bag. Okay. In other words, in mathematical form, this is this one. Okay, mu A equals to mu B. And if this claim is wrong, then the statement that will become true is, of course, the complement, the logical complement, which is mu sub A not equal to mu sub B. Yeah, I think that's enough. So again, going to our routine. Out of these two statements, we select the one with that contains equality to be the null hypothesis, and the one that contains inequality to be the alternative hypothesis. So in this case, it's very clear, it's no-brainer. So the first statement becomes the null hypothesis, and the second statement becomes the alternative hypothesis. Right? Next, we calculate the test statistic. Now, because sigma A and sigma B are both known, soon to be known, then we can use Z statistics. Okay, so we use Z naught as the test statistic. And because we're testing the equality of means, not difference in mean, okay, but we test for equality of the means, then of course the delta 0 is set to be 0. Okay, right? Because we are testing equality of means. In other case, we might be interested in testing the difference of mean. Okay, so for example, maybe we want to prove that machine B is consistently giving a mean filling weight of 5 grams larger than machine A. That means we're testing difference of means. Okay, so in other cases, we might want to test difference between means. Right? So if you want to do that, then delta 0 is not 0. Yeah. Okay. Now, in this case, we want to test equality for means. Right, so all we have to do again, just to plug in the numbers, and we obtain Z naught to be 2.06. Okay, and the critical value of Z can be obtained using table or Microsoft Excel. Oh yes, by the way, please watch the tutorial video that I have uploaded, because That video also contains how to perform hypothesis testing using Microsoft Excel. Okay, I'm not going to explain that here because it's quite easy. Okay, the one thing that I want you guys to be careful about is the command in Excel that we can use to bring out to look up the critical values, the critical value of T, critical value of Z, and so on. So you have to be careful with those functions. I believe I've already explained the peculiarity or the quirks of the functions in Excel in my videos. Okay, so make sure to watch them. Oke, jadi ada kalau melaksanakan uji hipotesis sendiri itu gampang banget dengan Excel ya. Yang kalian harus hati-hati adalah kalau kalian ingin melihat nilai kritik dari tabel elektronik yang ada di dalam Excel. Apakah misalkan kalian mau mencari nilai Z kritik atau nilai T kritik, itu yang kalian mesti agak hati-hati. Ada beberapa quirks atau ada beberapa keunikan dari fungsi-fungsi yang ada di dalam Excel. Oke, itu ada di video yang sudah saya upload. Oke, so the critical Z value is obtained from the table or from Microsoft Excel using this function here, norms INV, okay. Yeah. And this turns out to be Z equals 1.645. Yeah. Yep, there you go. So each of these areas are 0.1 divided by 2. Now remember, the total alpha is 0.1, so if we divide it by 2, the left-hand side alpha would be 5%, and the right-hand side would be 5%. Okay, the total is 10%. Yeah, and the Z0 is located there. Okay, so clearly it is located in the rejection region, right? So we say that there's enough evidence to state that the means of filling weight of machine A and machine B are not the same. Okay, so there's enough evidence to reject 8.0. Yeah. Okay, I think this one is pretty clear. Let me move on to the next one, which is a little bit more involved, which is hypothesis test based on two small samples, two independent small samples. Okay. Now the case is measurement of water pollution. Ya, ini kasus berikutnya adalah pengukuran kadar pencemaran air, ya, air di dalam waduk akibat acid mine drainage, ya, limpasan air asam tambang. So what is air asam tambang? So as we dig out minerals, for example, coals, okay, the soil in the hole from which we dig out the minerals, the remaining soil is usually acidic. So when the hole, okay, when the hole in the mining are filled with water, rainwater, for example, and that water then is then moving to other bodies of water like rivers or lakes, then the water will increase the acidity of the surface water. Ya, jadi galian tambang, lubang bekas galian tambang itu seringkali berisi mineral yang asam. Jadi kalau dia kemudian terisi oleh air, misalkan air dari hujan, ya, runoff surface water dari hujan. Nah, air hujan yang mengumpul di dalam lubang tambang ini biasanya bersifat asam. Nah, kalau ini kemudian bocor ke lingkungan, misalkan ke badan air seperti danau atau sungai, maka dia juga akan meningkatkan keasaman air sungai tersebut. Okay, and that constitutes a form of environmental pollution. Okay, so these are the chromium. Okay, dissolved chromium content in two reservoirs. Okay, and it is measured from the fish. Okay, so what this researcher did was they collect fish examples, yeah, they catch several fishes from both sites, from unpolluted dam and from the polluted dams, and then they, well, they of course they have to kill the fish, right? And they measure the amount of chromium contained in 1 kilogram of fish body mass. Okay, so this one, so each number represents one fish. Okay, so they collect 1, 2, 3, 4, 5 fishes from site number 1 and 4 fishes from site number 2, where site number 1 is suspected to be the polluted site. Yeah. So we want to prove the claim that that pollution did occur at a significance level of 5%, right? So if we perform some quick calculations from the obtained data, this is from the first site number 1, which is assumed to be a polluted site, and this one is from the non-polluted site. Okay, the mean chromium content of the first site is 0.6, and from the second site is 0.5. The sample standard deviation. Now we don't know the sigma. All we know is the S. Yeah? Is the sample standard deviation. Okay, so standard deviation of sample 1 is this one, and this is from the second sample. Okay. The claim that we want to prove is that pollution has occurred. Okay, if the pollution has occurred, then of course mu1 becomes larger than mu2. Right? And if that statement is not true, then the one that is true is that mu1 equals to mu2. Sorry about that. Hang on a second. Hang on 1 second. All right. Sorry about that. Okay, so this is the hypothesis statement. Okay, again, everything is straightforward. There, okay. So the original claim is pollution has occurred, right? So mathematically, the first statement is mu1 larger than mu2, right? Which means pollution. Pollution is proof. Okay. If that statement is not true, then the one that becomes true is this one. Sorry. Okay. And because this one contains equality, then this one becomes the H0 and that one becomes the H1. Okay. Like you see here. All right. Now, because this is a two-sample t-test with small samples and sigma is unknown, then you have to check the equality of variance first. Okay, because you have two sets of formula. Ya, jadi kalau kalian dihadapkan pada situasi seperti ini, okay, uji T terhadap dua data independen dan sampel kecil, maka kalian harus melakukan uji kesetaraan varians dulu. Karena nanti rumusnya beda-beda antara variansnya dianggap ternyata sama atau variansnya nggak sama, itu diatur dengan rumus-rumus yang berbeda. Yeah. So you need to perform a variance equality check first using an F test. Yeah. So, right. So we calculate the F0, large variance goes on top and smaller variance goes to the bottom. Okay, and the result is the F0 is 2.1, and the critical F values. Okay, this is the numerator degree of freedom. That is the denominator degree of freedom, right? And the critical value turns out to be 9.12, and you can use the F inverse function in Excel. Okay, so in Excel, this would be done by using this command. Okay. Okay, so that's the F distribution with degree of freedom of 4 and 3. And that's your critical F value at the F0. Oh, sorry, that's the test statistics. The F0 is 2.110 and the F critical is 9.12. It's far away to the right-hand side, to the right or to the outside of the F0. In other words, conversely, the F0 is far away to the inside of the rejection region. Okay, so there's not enough evidence to reject the null hypothesis for the F test. Remember, this is the null hypothesis for the F test, not for the T test. In other words, the results say that variance of site 1 is statistically not different from variance in site number 2. So therefore, we have to use this set of formula. Okay, so this is the set of formula for equivalent standard deviations or variances. Okay. Jadi rumus ini berlaku untuk jika varians A dan varians B ternyata tidak berbeda. Ya, jadi hasil dari uji F tadi barusan ternyata varians A dan B itu tidak berbeda secara berarti. Maka kita gunakan set rumus yang ini. Kalau ternyata hasil F test tadi menunjukkan bahwa varians A nggak sama dengan B, maka rumusnya bukan ini yang dipakai. Ada satu lagi, ya. Alright, again, all we have to do is to plug in the numbers to this lengthy equations. Okay, this is called pooled variance. Okay, pooled variance. This is some sort of like a average variance. Okay, variance rata-rata, something like that. So we obtain the degree of freedom to be 7. Yeah. The pooled standard deviation would be 0.0359 and the T0 is 1.999. Okay. Next, of course, we find the critical T value for a one-way or one-tailed test. Okay. And one-tailed test, of course, is right-hand side. Okay, remember the sign for the H1. It's mu1 larger than mu2. So this is a one-sided right-hand side. Okay. So the critical T value is this one. Okay, 1.894. Yeah. The 7 again. I should emphasize the 7 is obtained from that formula. Okay. Right. Yeah. So the t-test, the T0 is 1.999 and the critical T value is 1.894. Yeah, so we can see that the T0 is slightly to the outside of the critical T value, or it barely enters the rejection region. Yeah, so we say that because T0 resides in the H0 rejection region, then we say that there's enough evidence. Okay, there's enough evidence to reject H0. In other words, there's enough evidence to support the claim that there has been an increase in chromium content due to pollution. Yeah. Now remember that the original claim is associated with H1. So refusing H1 is the same as refusing H0 is the same as accepting H1. Yeah. Oh, sorry. Okay. Any questions here? I think it's pretty straightforward. I know it's quite lengthy. One of the more important concepts in this two small sample t-test is that you need to check this one first. Okay, you need to check here. You need to check the equality of variance before you do any other calculation. Yeah, so you have to check this one first before deciding which formula to use. Okay. All right. Any questions? Okay, our time is up. So I will let you guys read the last one on your own. Okay. This is a paired t-test. Okay. Uh, the procedure for paired t-test is totally different from independent t-test. Okay. So we work with the average difference between pairs. Okay. And when it comes to paired data, we always use t-test. So there's no such thing as paired z-test. Okay, because when people do this this paired experiment for practical sake, it's not practical to perform paired data for large samples. It's difficult to measure. So therefore there's no such thing as paired z-test. There's only paired t-test, because when we work with paired t-test, usually the sample sizes are small. Okay, for practical reasons. All right. Okay, if there isn't any question, that's it for today. And again, I need to remind you that we will post a homework. Okay, the homework consists of 3 numbers, if I'm not mistaken, and that needs to be turned in next week during the class. Okay. All right. Thank you very much for your attention, and we'll see you next week.
Thank you, sir.
Thank you very much, sir.
Thank
Yep.
you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you.